So now let's understand how to fine tune a chat completion model. So first of all, we would need a suitable foundation model. So first of all, our task is we need a suitable foundation model for our tasks. Then we would need a training data set. So training data set would be, because it is a chat completion model, so it would be like example of prompts and responses. So that would be the kind of our training data set. And we need to find a suitable foundation model. So the quality and amount of data greatly affects the training quality, right? So we should have a quality data. By quality data, it means like it should cover each cases. It should be, you know, it should not just be one type of cases, like one type of prompts and one type of responses. It should have a variety, right? And amount of data also affects, although we need less data for fine tuning, but we still need enough data. So that's how the data, the training data sets, quality and amount affects the quality of training, right? So to fine tune model for chat completion, so data will be a collection of sample conversations. So it will contain a system message, user message, and assistant response, right? So all of this will be in a format JSON-L. So JSON-L is basically JSON lines. So it's a text-based data format where each line is a separate JSON object. So although here you can see this chunk, so this is basically a line. So in one line there is one JSON object. So that is what we mean by it is just JSON. Just the difference is that in one line there is only one JSON object. So that's why we are calling that format JSON-L format. So we will provide our data in JSON-L format. So this will be like this messages, and now there will be a role system and the content. So it is the system message. Then there will be a role user, and the content is Xbox better than PlayStation. So this is the content. Then there will be a role assistant and contents. I apologize, I cannot provide personal opinions, my primary job. So this is the um, basically the response that assistant should give, and this is the user's query, and this is the system prompt, right? So this is the format for the JSON. So you can understand we are getting a dictionary in which there is a role and content key. So role, we tell what is the role, system, user, and content is basically whatever the content is. So it's basically the list of these dictionaries, and in each dictionary there are two keys, role and content, right? So it is the messages are basically this list. So you can understand there is messages key, and in messages key is basically a list, and that list is a list of uh, you know dictionaries in which there are two keys, role and content. So another thing that you have to take care of is you have to remove the personal and sensitive information in the data set, so that it is safe. So you should remove that information from your data set, and you should also ensure that you have a diverse set of examples. There is a diversity in examples. It is basically covering all the cases. So now weight key value pair. So if you understand what a weight key value pair is, so if the weight is 0, then the message is ignored. If the weight is 1, then message is included in training. So if you want that particular message should not be used in training, and the particular message should be used in training, then we can utilize weight key value pair. So as you can see in this, is this JSON-L or in this JSON object. So again we have roles. So it's system, and this is Marv is a factual chatbot that is also sarcastic. So that is the system prompt, right? Then there is user, and which is like what is the capital of France. Then the assistant gives the content Paris, and the weight is 0. So weight 0 means that this message should be ignored, and this should not be used in training, right? So this is the way of specifying that we do not want this for training, right? And then the next role is user content. Can you be more sarcastic? And the role of assistant and the content is Paris, as everyone doesn't know that already, right? So here we put weight 1. So in weight 1 means that this message should be included in the training. So that is what we mean by weight key value pair. So we are specifying one more key weight which has a value of 0 or 1. So based on that, we are telling that this specific assistant message should be included in training or not included in training, right? So let's understand how to fine tune language models in Azure AI Foundry portal. So first of all, uh, now we understand, that how what kind of data we want. We now are moving to our model. So how we will select our model. So to select our model, in Azure AI Foundry portal, we have a model catalog. So first of all, we need to understand what kind of task we are performing. So we will select the fine-tune base model based on that task. So that task could be text classification, translation, chat completion. Based on the task, we are selecting the base model, and we are selecting only the base models which can be fine-tuned, right? So for that, in the model catalog of Azure AI Foundry, so we find a base model specific to our task. So there is a filter option there, and you can just use the fine-tuning tasks in model catalog and select your particular task to go to that model. So what kind of things we should basically examine? So from the model card and model description, these kind of things should examine in our model, like what are the capabilities of model. So what is the training data, pre-trained data, right? And what are the limitation and biases, and what kind of languages it support. So these things we should examine in our model, the in our base model that we want to fine tune. So now let's understand configuring fine tune job. So configuring fine tune job is very simple. You will first select the base model, right? Then you will give your training data and validation data, which is not compulsory, it is optional, but it's recommended that you also give the validation data. You have the training data and the base model. So all of this you will give, and you will configure some advanced options, and then you will give this to your fine tuning job. So fine tuning job basically means that it will do the fine tuning, right? And give us a new fine tuned model. So that is what we are doing here. So let's understand what advanced options are here. So let's understand first of all the advanced option of number of epochs. So as we know, epoch is one full cycle through training data. So whatever our training data is, when all that training data has been passed, right? So that is one epoch. So an epochs basically tells how many epochs you want. So like our algorithm, how many times it will see the training data. It's basically what that means. So the next is seed. So it controls the reproducibility of job. So you might have used seed in random generators, right? So it basically controls the randomness. So the seed basically controls the reproducibility of the job, right? And then let's move to batch size. So batch size is what? Is the number of training samples or training examples for a single forward and backward pass. So we basically how many number of examples, how many number of training examples we want in one of the batch size. So it is basically how many training samples go to the forward pass and then the backward pass, and based on that updation is performed. So after we can say, like after this 100 samples are being uh, passed in the forward pass and then the backward pass, so it's basically how much updation we want. So if the batch size is large, you know there will be less frequent updates. If the batch size is small, there will be a lot of updates basically updating those parameters. So updating the parameters of model, right? So if we have a large batch size, those updates will be less frequent, and if we have small, then those update will be more frequent. And when the updates are less frequent but there is a lower variance, why there is a lower variance? Because uh, parameters are updated on a large sample. When we have a large batch size, there are more samples, so parameters are updated on large samples and they are stable and less noisy, right? And we also get faster convergence per epoch if we have a large batch size. So we can basically uh, configure these batch size, number of epochs, seed, and learning rate multiplier. So let's understand what is this learning rate multiplier. So there is original learning rate. So on the pre-trained model, our pre-trained model has its training is its learning rate, its original learning rate. So if we multiply that original learning rate with the learning rate multiplier, then we will get fine-tuned learning rate. So when we fine-tune our model, it will use this fine-tuned learning rate, right? It will not use the original learning rate. So we want, if we want what kind of fine-tuned learning rate we want, we will use this multiplier for that. So this multiplier will basically multiply that original learning rate, and then we will get our fine-tuned learning rate. So smaller prevents like overfitting. So if you put a smaller learning rate, it will prevent overfitting, and so larger is good for larger batch size. So yeah, so this is all about the learning rate multiplier. So after we have set all these advanced options, we have selected our model, and we have also our training and validation data. So the next thing to do is run the job. So we will run the job, and then we will check the status of job, whether it's complete or not, and how it's going. So we'll check the status of the job, and after the job has been done, what we can do is we can review the input parameters to understand how fine-tuned model was created. So we can understand for which input parameters the performance was good, or which input parameters the performance was not good, and based on that we could understand like how the fine-tuned model has been created, right? The next thing, if we have a data set, we can basically review the model's performance on that validation data set, that how well it was performing on the validation data set. If we do not have the validation data set, then or the next step we could do is we could deploy our fine-tuned model. So we will deploy our resultant fine-tuned model, then we will test it, using some queries and checking if the responses are correct, right? So we could use other method also. So we will deploy fine-tuned model, and then we will test it, and if we are satisfied with it, then we will use that in our application.